All right, welcome back to another episode of Science with Surbat. Today what we're going to be talking about is how atoms differ. Now, before we get going into these notes, there's a few objectives that I would like you to be able to meet by the end of this video. Objective number 1, explain the role of the atomic number in determining the identity of an atom. Objective number 2, define an isotope and explain why atomic masses are not whole numbers. And objective number 3, calculate the number of electrons, protons, and neutrons in an atom given its mass number and atomic number. So we'll get going with these notes here, and we will start out by using some of the information we learn in notes as well as the periodic table. So it'll be helpful to have the periodic table handy. Okay, so what we have just talked about is the subatomic particles in the last section. So protons, neutrons, and electrons. And we learned about how they were discovered and where they are in an atom. And now what we're going to do is we're going to utilize that information for our purposes in this class. So what we start out here is with our atomic number. Now, the atomic number is the number of protons in the nucleus. And what we'll talk about down here is that the atomic number is equal to the number of protons in each element. Okay? So the atomic number, if we take a look on the periodic table, the atomic number you can see is in the upper left-hand corner of the periodic table that we will utilize. That determines the position of that element in the periodic table. Now, just from looking at that periodic table, the numbers get larger moving left to right and from top to bottom in our periodic table of elements. And now we have two important things. Number one, in a neutral atom, so no charge, protons equal electrons. Now, the next thing here is very important, and I'm going to pause to write this down. The atomic number is equal to the number of protons. And to go along with this, I will say this. The number of protons determines the element that you are working with. This means that if we change the number of protons, we are dealing with a different element. So let's go on here and let's put this trial to the test where we have the atomic number equal the number of protons. And so what we're going to do is we're going to fill in this chart. And so we want to assume a few things. One, all atoms are neutral, okay? So in this, I'm going to utilize the periodic table as well as the information given in the chart to complete this entire table. So we start out with the element symbol Pb, which Pb, if we found it on the periodic table, is element number 82. Now that 82 on the periodic table, and I can zoom in here, the 82 represents that we have an atomic number of 82, and that means we have 82 protons. So in the number of protons here, I'm going to put 82, and that's because the atomic number is equal to the number of protons. Now remember from that last slide that the number of protons is equal to the number of electrons because an atom is neutral. So there is also 82 electrons. Now this next portion here doesn't give us much information except the number 8. Now, the number 8 is located under the protons, and remember, the number of protons is equal to the number of, or the atomic number. So what I'm going to do is fill in the atomic number 8, and on my periodic table, I'm going to find the element with atomic number 8, and I find the symbol O for oxygen. So under that element symbol, I'm going to put O for oxygen. And now in a neutral atom, remember the number of protons is equal to the number of electrons, so we also put 8 here. Now, again, we're getting all of this information from this. The atomic number is equal to the number of protons. All right, moving on here. In a neutral atom, we have 30 electrons, so that means we would have 30 protons. Now, from our statement we just wrote down here, the atomic number is equal to the number of protons, so that means we also have an atomic number of 30. So what we need to do is we need to look on our periodic table, and we need to find the element with the atomic number of 30, and we find the element symbol Zn for zinc. So again, very simple task here, but we're looking for that whole number, the atomic number on the periodic table, which is equal to the number of protons, and because we are neutrally charged, we have the same number of electrons. Okay? So now, let's go ahead, let's keep moving on with this information that we have here. And we get to isotopes. So remember way back in section 1 when we said, all right, Dalton's theory is pretty good, but there was 2 flaws. One of the 2 flaws was he says that elements of the same, atoms of the same element are identical. This is not true because of isotopes. So isotopes say we have the same number of protons, but different number of neutrons. And so let's take an example here of what I mean here. So with potassium, we have 3 naturally occurring isotopes. The first thing that we have to understand is that every single potassium atom has 19 protons. Remember, if we change the number of protons, we change the number, or we change the element that we're working with. However, depending on what type of potassium we have, or what isotope of potassium we have, will determine the number of neutrons. So you can see here the 3 versions of potassium will have varying number of neutrons. The other thing that I want you to notice is this. If we take a look on the periodic table, we find potassium, which is element number 19 for the atomic number 19 and the number of protons. We also see another number here, and that is the atomic mass. Okay, so the atomic mass is this decimal number. Well, you may be wondering, okay, if we had whole numbers here, how exactly do we get to this decimal number? Well, in reality, these isotopes, these different versions of each and every element, is going to have a different abundance. So there's going to be different amounts of that particular element in the Earth. What we can do here is we can utilize this portion right here, and we can perform a calculation to find out that particular number, the atomic mass that is seen on the periodic table. Now we're going to revisit that because we first have to talk about mass number. How do we calculate that in generic or general terms? So keep this information in the back of your mind here. We'll get to it at the end of the section. And I want to talk about the mass number. Okay, the mass number is the sum, so the addition of the protons and the neutron. Again, what we have here is the mass number is equal to the number of protons plus the number of neutrons. And now I want you to note this. Just because we have a mass number, it's not going to determine the behavior of each and every atom. That's determined mainly by your protons in the nucleus, but also has a reflection on the electrons in an atom. And as we're here, I just want to write this in shorthand notation. So this same formula here, I'm going to write to the side, is mass number is equal to number of the protons plus number of the neutrons. Okay, and we will utilize that. We'll write it down time and time again. What we also have to remember is how we can express the isotope of different elements. we have two different ways that we can list out the isotopes for each element. One is the element name notation, where we write out the entire element name, and then we put the atomic mass to the right of that element name. The second is the element symbol form, where we put the element symbol, and in the upper left-hand corner, we put the atomic mass of that isotope, and in the bottom left-hand corner, we put the atomic number or number of protons of our element we're working with. Now, there's a lot of information here. We threw a lot at you. Let's go ahead, let's do an example so we can hone in on the details discussed here on this slide. All right, so it says here, a chemistry laboratory has analyzed the composition of isotopes of several elements. The composition data is given in this table below, and we want to take the data obtained for one of 3 neon's isotope, and we want to determine the number of protons, electrons, and neutrons in this particular isotope of neon. We're going to name the isotope and give its symbol using both of those notations that we just said. All right, so the first thing here is I am going to highlight neon so we identify what row we are working with. Okay, so neon is this top row here, and it has an atomic number of 10 and a mass number of 22. So what I'm going to start out with is this. We, in the question here, it said determine the number of protons, electrons, and neutrons in the isotope of neon. So all I'm going to do here is I'm going to write out protons, electrons, and neutrons. Okay, so we have to go through our process that we have just learned about in both the atomic number and the mass number. So down here, what I'm going to put is this. The atomic number is equal to the number of protons. So the number of protons will be very easy to find. Again, we look at the atomic number, which is given at 10. That is equal to the number of protons. Now, in a neutral atom, so a neutral atom has equal protons and electrons. So the number of protons is equal to the number of electrons, so we can also put that down as 10. And the number of neutrons is what we're going to have to calculate. So what we're going to have to do to find the number of neutrons is plug it into our mass number formula. So down below here, I'm going to put the mass number is equal to the number of protons plus the number of neutrons. And all I'm going to do is insert what we have already found in this formula. So the mass number is given at 22. So 22 will be our mass number. It is equal to the number of protons, which we determined that we had 10 protons. And then what we don't know will be our variable, and that will be our number of neutrons. So simple algebra to get 10 by itself, it's connected by multiplication. We just subtract 10 on each side. And so 22 minus 10 leaves us with 12 neutrons. And so 12 would be our neutrons. Now we have to go through and we have to put the isotope notation both in the element symbol and the element name form. So what we have here, I'll call this the element name, and you might see this listed as the longhand notation. And so what we're going to do here is this. We are going to first write out the name of the element. So the name of the element is given as neon. So I'm just going to copy that down, neon. We put a dash, and then after that dash is going to become the mass number. So the mass number, remember, was 22. So we put 22. Now that's the element name or longhand notation. If we have the element symbol, and sometimes I call this the shorthand notation. The shorthand notation, we start out and we write the element symbol name. So the element symbol for neon, which is element number 10, is Ne. So we'll start out here by writing Ne, and then in the upper left-hand corner, we put the atomic mass, or the mass number, which is 22, and in the lower left-hand corner, we put the atomic number, which is 10. So that's how we would write the isotope notation for this isotope of neon. All right, moving on to our last few things of this section of notes. We get to what we have known as AMU, or atomic mass units. And this is just a standard unit that we utilize to calculate the mass of the parts or subatomic particles in the nucleus. So by definition, this is 1/12 the mass of a carbon-12 atom. So essentially they took the mass of a carbon-12 atom, they divided it in 12 pieces, and that becomes the atomic mass unit used to measure the mass of an individual element. What we need to understand is that 1 AMU is equal to the mass of either a proton or a neutron. Okay? In reality, the actual mass of a proton and neutron is a little bit more than 1, but again, we're going to keep it simple in this class, and we're going to say 1 atomic mass unit is equal to either 1 proton or 1 neutron. Okay? The other thing that we need to identify, or we need to go through in this particular section, is how they calculate the atomic mass. Now, on our periodic table, you should notice that there's this decimal number. Up to this point, all we've dealt with is whole numbers. Each and every single isotope has a different whole number for both its mass, number of neutrons, and protons. So how do we get that particular how do we get that decimal number for the atomic mass that is listed on our periodic table? Well, we get a weighted average, and it's not as simple as adding all the isotopes up and dividing by however many isotopes we have. We have a particular way that we calculate it. Because of this, it's going to result in a unique mass for each and every element. So what we're going to do here to identify or to calculate the atomic mass of an element is we're going to identify all the isotopes of the element. We're going to take the atomic mass of that particular isotope and multiply it by the percent abundance that's given. And then once we've done that for every single isotope, we're going to add the values together, and that is going to become our particular atomic mass. So the easiest way to go through these steps is to actually do a problem. So we start out here with this table, and it says in the data table below, we want to calculate the atomic mass of unknown element X. We then want to identify the unknown element and give the symbol notation of the particular element. So we start out this with the isotopes. And since we don't know it, we say this is isotope with an atomic mass of 6. What we're going to do first is we are going to take 6.015 AMU and we're going to multiply it by the percent abundance. However, this is a percent. We are going to transfer this to decimal form. So the way we do that is we punch in 7.5, that's the percent, and we're going to divide by 100 because it's percent. So in decimal form, I'm going to write this next to it, we have 0.075. So up here, what we're going to do is we're going to write down 0.075. Now, in our calculators, what we're going to do is we're going to take 6.015 times 0.075. We're going to press enter, and we're going to write down 4 decimals. So we're going to say this is 0.44511 AMU. Okay. The next thing that we're going to do is we're going to write down that next isotope, which is element unknown with that atomic number of 7. We are going to write down the atomic mass of that particular isotope, which is listed at 7.016 AMU, and we're going to multiply it by the percent abundance in decimal form. So again, we're going to start out by putting 92.5, and we're going to divide it by 100 and write down 0.925. 0.925 is just 92.5% expressed in decimal form. So we're going to take 0.925 and we're going to put it right next to that atomic mass. We are then going to turn back into our calculators. And so what we're going to do is we're going to take 7.016 times 0.925. We're going to press enter, and again, we're going to write down all 4 of these decimals. So we're going to end up with 6.4898 AMU. Now, what we are going to do from this point is we are going to add these numbers on the very far right hand side. So what we're going to do is I'm going to type in 0.4511 plus 6.4898, and I'm going to press enter. So I'm going to get an atomic mass of 6.941. I'm going to round this to 6.941. This 9 causes that 0 to round up. So again, 941 AMU. Okay. Last thing I need to do here is I need to find what element has an atomic mass of 6.941. So what I'm going to do here is I'm going to look across my periodic table, and again, I'm looking for that little number, the decimal number, and I notice here with the atomic mass of 6.94, I get the element lithium. All right? So the unknown element is lithium. Now, you can either put Li, the symbol notation, or you can put lithium, and that would become our answer along with the atomic mass that we have calculated. All right, so we will get more practice at both doing the atomic mass calculation, finding the number of protons, neutrons, and electrons of a particular isotope, and we will also get more practice at calculating the atomic mass of an element. Hope you have enjoyed this particular episode, and as always, make sure you subscribe.